Thermodynamics is an interesting physics topic which has amazing ideas such as entropy in its core. However, a rule that has been in its place for almost 200 years has been broken down. What is this rule and how did we break it? Okay, so the Carnot rule has proved that no engine can be more efficient than a limit set only by two temperatures. What does this mean? Basically, we consider heat as the only form of energy at a macroscopic level, so efficiency is said to only depend on temperature. The only way to have 100% efficiency was if the object which work was done on is at absolute zero, which has never been plausible. This rule is one that has dominated engineering and heat designs for the longest time, having a valid effect on macroscopic systems. But can this be said for microscopic systems as well, about molecular size? This is what Professor Eric Lutz at the University of Stuttgart said to test. These results may actually shock you though. Carnot demonstrated that the temperature difference has a decisive influence. The greater the difference between hot and cold, the higher the maximum possible efficiency of a heat engine. However, the Carnot principle neglects the influence of so-called quantum correlations. These are basically special bonds that form between particles on a very small scale. For the first time, the researchers have derived generalized laws of thermodynamics that fully account for these correlations. Their results show that thermal machines operating at the atomic scale can convert not only heat, but also correlations into work. As a result, they can produce more work, and the efficiency of a quantum engine can surpass the traditional Carnot limit. Their work deepens our knowledge of the world at the atomic level. The better we understand the physical laws that apply in these dimensions, the sooner we will be able to use them to develop technologies for tomorrow. Maybe even such as tiny, highly efficient quantum motors that can precisely perform tasks at the nanoscale. Perhaps one day, such motors will power medical nanobots or control machines that process materials at the atomic level. The potential for this type of technology is enormously diverse. So basically, quantum correlations at the molecular level also supply energy, and thus make small motors more efficient than big ones. Sort of in the computer sense, where transistors get smaller and smaller and computers get more and more efficient. Imagine a motor a billion times smaller than your fingernail. That may be what is to come in the new and exciting future. If you guys enjoyed this video, consider subscribing. It helps me make epic videos like this as often as possible. Be curious like a child, the world needs more of it. Bye!